Hi, everyone. This is your host today, again, Nikola Cvetkovic, the founder of No Limit Hub, an NGO that hosts and runs CODEstantine meetups and conferences, one of the biggest events for developers in Serbia. And recently we started doing the global tech talks where we bring speakers, industry experts to talk about interesting topics that we believe would be interesting to our audience of mostly experienced developers. So as I said, my name is Nikola Cvetkovic and I'll be hosting the event today. Our sponsors of the event today is CODEstantine, a young company that has a development team here in Serbia, and over the last couple of years they've grown to almost 80 people, and they're constantly working with foreign clients to help them deliver top-notch technology services. They're passionate technologies, and what they say about themselves is they really try to understand and help their customers by understanding the business and the technology that they need to bring to them in order to provide the high value. So go check out their website. And today we'll be having two great speakers, Milos and Bojan. Hi, guys. Welcome to CODEstantine, who will be talking about how to deal with microservice architecture challenges in the real world. We'll be covering this topic with a couple of real-world examples that they'll be sharing, and I'm pretty sure that all of you who have been working with microservices, which is today kind of a new norm and like expected for everyone to kind of have a microservice architecture, that you have come up with a few examples, with a few drawbacks and problems that we're going to talk about today. I know that me working in a couple of startups and the company I run, Product Hive, we did already encounter some of the problems that Bojan and Milos will be talking today. So I'm really looking forward to speaking in more depth and asking some questions. We have a large audience with us today. As you guys can see, we do have a slightly different interface than the last time, and I'll be playing around with these different views to try to help you follow along in the best possible way and have the best experience. I want to thank No Limit Hub, an NGO that's behind organizing CODEstantine events, and also organize a couple of other interesting ones like Kick-Ass SaaS, which is like a knowledge platform for SaaS founders. So go check out that as well if you're interested in learning more about business topics about starting a technology company. Just a couple of words of intro about our speakers today. Milos and Bojan. Milos Garunovic is a backend developer for logistics software, working on third-party migrations. Previously, he worked in healthcare industry, developing the architecture for third-party integrations and improving the third-party integrations architecture overall, simplifying code base and maintenance. He's passionate about new technologies, helping others, and sharing knowledge. That's why he's here today. He held seminars about productivity in IntelliJ in Belgrade and Novi Sad. We do also have a very interesting topic on productivity in IntelliJ on CODEstantine website and social media, so go check it out. We had one a few weeks back, and it was really, really good. Milos likes to spend his free time cycling, touring, backpacking, hiking, playing bass, and developing apps for personal use. So if you need an extra bass player in your band, you know who to call. In the other corner, Bojan Milic is a Java software engineer at CODEstantine. After working in the gaming industry, creating applications for VR technologies, Unity and Unreal Engine, if I'm not mistaken, Bojan mostly. After that, you were a lecturer on eCampus, University of Milano, and have since devoted your time in building Java applications and microservice with the microservice architecture. So you would say for yourself, you're a nature lover, scuba diving instructor, active runner, hiker, keyboard player, a fan of cars, and occasional work on them out of the pure hobby. So we have a bass player and a keyboard player. So if I knew to play anything, we might be able to form a band. But since I don't, I guess you guys are doomed to working in development throughout your career. So cool. So today we'll, as we mentioned, we'll be talking about microservice architecture challenges in real world. I won't be sharing a lot about the topic, so I'll leave it to you guys, but to present it. So go ahead, jump in, and I'll be probably jumping in and asking some questions here and there. Everybody who are on the session, please feel free to actively participate and leave your comments in the comment section on the right. We would, I will keep an eye on them and make sure that we answer most of them, that they are answered by the speakers. So thank you very much again for being here. Go check out CODEstantine website for some of the past talks. Follow CODEstantine on social media, as well as No Limit Hub. And Milos, Bojan, the floor is all yours. Sorry.
Greetings, everyone.
Introduction.
Yeah. Yeah, thank you, Nicole, for this lovely introduction. Greetings to everyone, and me personally, I'm really happy to be here, and I really hope that everyone can hear me properly. Fun fact, we are having our own band. It's called Q-Series Commit, because we are kind of programmers, and definitely, Nicola, we would take you as a, you know, as a front man, as the guy to talk with the audience, with everyone else in the front line. So yeah, you can send us your CV or something like that. That would be awesome.
Yeah, thanks for the introduction. I don't have much to say. Without further ado, we can start the seminar, starting with Bojan.
Thanks. Thanks to everyone. Please, guys, if anyone have any question, please write that question in the comment section down below. We're going to try to answer all of them, or at least the most interesting ones. At the end of the, you know, this small seminar, we're gonna call it like that. We have a Q&A section in the end, so we're gonna follow up there. If you have any problems with hearing me, please write that down in the comment section so we can fix that. When we were talking about what we're going to talk in this session, in this seminar, the first question I had is, who will be in the audience? What will be the seniority of the people in the audience? Because that's really important. Should I talk something like what's new in Java 17, what's new in this? It's kind of boring things. So let's keep the topic interesting and fun for most of the attendees here. So I was thinking and talking to Milos, what is the new standard? So for the past few years, everyone is talking about microservice architecture here and there, but I believe that really soon, no one is going to say, yeah, we're doing microservice architecture because that's going to be the standard way to do it. That's going to be a norm. And that's why I'm having a thought that everyone should be able to think about the problems that microservice architectures are, having, and the things that you should think ahead of implementing your first or second or 10th microservice application.
So, okay, I see that, Milos, you did mute yourself. There was a slight microphone.
Maybe it also comes from you, Nicola. Please, can you try to mute yourself too?
Yeah, sure.
Thank you. So it doesn't matter which type of architecture we are talking about. Every problem and solution starts and ends up with checking the logs. If you create a new feature, you're checking the logs if that feature works. If there is a bug in the system, first thing that you'll ask, oh, show me some logs so I can see where the problem actually is and how to work with it, how to find the actual the root of the problem, the cause of it. But microservice architecture, it means that multiple services are logging some different logs differently on different servers, whatever. So there are multiple things that we have to take care of for microservice architecture. And the challenges that we are gonna see here is that services may be span across multiple servers, or even they be spread across multiple geographical boundaries. For example, your microservice application can be created in multiple languages, coding languages, and some of them are having different way of logging. Sometimes you may cooperate with some different company, so you want to unite two different microservice applications into one. So some of them are having logs over here, some of them are having logs over there. So those are the problems that you have to take care of. Also, different type of microservices, they are maintaining their own set of data. So you have to take care of it also. Different way of storing, different way of logging, the logic behind it. Many different things that you have to take care. And in the end of the day, you have to make sure that all of your workflows and new implementations, new features, fixing the bugs, you have to be able to determine how and why some microservice is experiencing an issue, how to fix it, and to approach the solution to the problem. And I'm gonna tell you a few different best practices for logging and managing the logs in the microservice application. First, and kind of obvious, is that your microservice application is having multiple services. That's why it's called microservice. It has multiple microservices, and it's really rarely a situation where one service will be enough to do like most of the work. Most of the times we make some API request, and then the one microservice is taking the request and then asks for something to another application, that another application asks third application, and that workflow can be really, really long. So from the start of the one API request until the end of it, we will have multiple ways to that our data will flow through multiple services. And that's why you have to use some kind of correlation ID that will connect all those logs into one huge chain of logs. That correlation ID can be called whatever you want. Correlation ID, slow trace ID, log trace ID, however you want, but keep them together. So for example, when you see some error, okay, I see an error, then I take the correlation ID, I search the whole logs that I have using that correlation ID, and I will see, where the problem started, how it came to become a problem, and how we actually took care of that problem. Next thing that we would like to do is to structure logs appropriately. Different languages are storing and saving the data in different formats. Maybe in my microservice, I was using separator, comma, someone else is using semicolon, someone is using dash, someone is using underscore. But keeping all those formats in the same way, same order, it will help you for better searching, for better and easier formatting and everything else that you have to do, especially when you have to parse the logs. What should you actually save in the logs? Well, it depends on the type of the log. Is it an API log? Is it a server log? And the option, maybe fourth, whatever. But having the service name that provided the log is really important. Also, I already mentioned the declaration ID. When that log was saved, stored, when that happened. So keep the timestamp. Mostly those timestamps should be saved in UTC because we are working all over the place in different time zones. So keep it in one unique timestamp format, for example, UTC. Keep either API body to see the body of the request or the body of the response. Keep the message if that's the server log, so you can see and you can write to yourself or to your future self or to your colleague what actually was the problem. It would be nice to keep also type of the request. For example, is it an internal server request? Is it a client request, a client response? Those things are really nice to have. Is it an error? Is it a warning? Is it just an information? Is it debug? Keep that level of the message. So it's really nice and good to have all those application informative levels there. All data should be, and it would be nice to have all of those data in one place. Especially if you're having multiple applications with multiple servers, multiple environments, whatever, it would be okay to have either a dedicated server where you will store all of the logs, or if you don't want to bother with it, you can just buy cloud. It should be S3 bucket, it should be Google Cloud, so Azure, whatever you want to, but keep those logs in the safe and central storage place. And what is the purpose of logs if you cannot, query them, if you cannot search them, if you cannot go through them and actually get some information from them? And there are lots of different tools, such as ELK stacks or so many others for displaying and visualizing those logs and seeing what's going on there. Of course, most of the time, not only having the crude text of those logs, that's fine. But if you can visualize the log data, that's really awesome. To see if you had an increase over here or decrease over there, or if you can visualize it through some percentile graph or whatever you want to do. It's really nice to have that. And we have many different tools for using those. And there are many different, architectural examples for storing the data. And I will show you one that is mostly used and really nice to have. We have on the left side few hosts, different servers, different applications. And all that logging data is going to Kafka. We're going to have a few words later about Kafka or any other, queue messaging systems. I would say it's for obvious reasons, but I will refer to that a little bit later when I'm going to talk about them. And that workflow will go through Logstash cluster, and then, for example, Elasticsearch cluster. And then finally, we're going to query those and visualize those logs using, for example, Kibana. This is the ELK cluster that I've been already mentioning. And now, not only the logging, but we have to take care of dependencies between our microservices. And that's something that Milos is going to talk about now.
Thanks, Glenn. So we have dependencies between microservices, which is usually the the data format in which microservices communicate with. Why are dependencies hard? Well, microservices are made to be isolated entities, so they can work independently, but they have to work with each other. So we have two services that communicate with each other. The problem is when you write a monolithic application, monolith, you usually have packages and everything like that in the same place, in the same code base. So you have a compiler and IntelliJ or whatever IDE you're using to check your dependencies. So if you make a mistake, the code won't compile. But in microservices architecture, when you compile the service, it works usually. And you need to know if it works with other microservices. So when you change the data between the microservice, when you change the data between services, you have to keep things in mind that you don't break other services that are dependent on yours. So that's kind of like backwards compatibility. You'll have to wait until all the services migrate data to a new format, and then only then delete the old data that you don't use anymore. So the biggest issue here is what to do with the data format changes, when the data format changes. Not sure if it works.
We are seeing the service 1 and service 2 graph.
Yeah. So the first way to deal with that is to have the same endpoint, for example, API/action. And the first my_enum is just a field that we're going to use that we need to update. So let's say my team want to expand the enum, but if you expand the enum, the new ones that are shown can break other services. So you have to introduce a new variable, like shown in the example below. So we have my new enum, and with that, it's not that great because we have some cons there. Seems that, yeah. So the pros first are, it's fast for development and it's easy to create new fields. But it comes with cons. Obviously, you have naming conflicts. So my new enum is a conflict because we want to use just my enum. The second one is that if you do this long enough, you can cause your requests or responses to be bloated with the fields that you don't use anymore, with usually with unnecessary fields, right? It's harder to track. So the logging part that Bojan talked about, you have to know who uses what fields in order to, at some point, migrate to just my new enum. And it's a bit harder to track like this. You have to track your body and everything like that. So to combat that, we use versioning of our endpoints. So instead of like previously API/action, we have API/version1/action. This version field can be placed in many places. It can be placed in URL, like here. It can be placed in header field, and it can be placed, for example, in body. But when you do it in body of a request, you want to have it like a wrapper, so you don't conflict the data that's necessary for the request and the metadata for the request itself. So this example is like when we version in previous example, my new enum, we don't have naming conflicts because we can name it the same, but we change the service. we don't bloat the request response because we make a new one. It's easier to track who's using which version, which comes back to logging again. And this is because you have two versions of API, so you can just query the URL if nobody's using version 1 for some amount of time. You can probably delete it or make it deprecated and everything like that, so you don't need it anymore. And after that, users can use just version 2, etc. Of course, there are some cons. It's slower to implement because you have to create a new service, which, depending on your tech stack, can be simple, obviously, but it can take a lot to implement if you have other services that your service is requesting data from. And the third way, which I don't recommend using, but it is a good way in some scenarios, is to use something like SDK. This would be in Java a jar, which contains all the classes that we use to communicate between services. So any new service can just get an SDK, implement everything from it that it needs. And the benefits are that SDK, so first of all, as I said, they share all the same code base. Second, it's compile time safety, which is really important because compiler is your, at least to me, best friend to track early errors. When you compile code, you know that it works at compile time, and if it works in one service, because it's an independent. Thanks, Nicola. Yeah, sure. Ask questions if you have some, or say something, or write your experience with something that we are talking about if you have anything new. Back to the topic. So compile time safety, all your services have everything the same. If you have validators, tests, and similar, it's all the same. You don't need to rewrite the code and similar. So cons, maintenance. The biggest problem with this is maintenance. You have another project to maintain, and every time you make a new version, every other service has to implement it, has to update the service. So you're developing a new project. As I said, frequent dependency updates. So every time an SDK changes, you need to update each service that uses that SDK. Yeah, that's this one. And the biggest flaw is that if you have multiple programming languages in your architecture, SDKs are usually for only one language. This usually isn't that good, and there are things that you can do like Swagger or WSDL to make it work between the services, and probably something like protobuf or something like that can work as well. So while we talked about what changes in format while communicating between the services, we didn't talk about how to make microservices communicate between each other. So that's what Bojan going to talk about.
Milos, thank you for handing this over to me, back to me. So I'm back, and we're gonna have a few minutes talking about communication between multiple services inside microservice architecture. And the biggest fight is definitely between synchronous and asynchronous communication between microservices, and that's the setup for, let's say, 3 different ways of communication. First of all, it's synchronous, and that is communication that happens in real time. We're gonna have a little bit deeper talk about it. Asynchronous, it kind of works independently in time. So let's say that no one is waiting for no one else, and some kind of hybrid communication, which supports both, or appropriate combination of both. And we're gonna stick to it for most of the topic. Now I tried to show mostly images, some graphs, and models, and having the least text as possible. So synchronous communication, as it states here, it's blocking interaction. What does that mean? It means that when I make some synchronous call, that would be API call, REST or SOAP. That means that I'm making a request and I'm waiting until I get back the response. So I don't know what that other side, what that microservice B is working. Maybe it has really complicated task, but I'm gonna wait for it. I'm, for example, microservice A. I made a request and I will wait for it. How long I will wait? Well, no one is going to wait indefinitely. So we're gonna set up the time to leave, that request timeout. And if microservice A doesn't get response from microservice B in that request time, that time to leave that we set up, then we kind of could have problems. And also microservice A is doing nothing. It's only waiting for microservice B to answer to it. That's, for one, that's really good because it's really reliable communication. So we are waiting. So we have a request and we will either get that response and continue working on the we're going to continue processing the data, or we're going to just say, oh, I didn't get the response. I'm going to log that exception and continue working. But in the other hand, we have this asynchronous subsequent response. What does that mean? It means that microservice A, it doesn't need the response from microservice B, but we really, really, really care about the data. We really care about the message that microservice A is sending to microservice B. We don't want to lose it. I basically don't care when microservice B is going to take that message and process it. I'm worried about not losing the data. Maybe that's money transaction. It's really important, or some bet for a football game that I'm looking for. So I really need that data to be saved. And that's why I'm going to use some kind of queue, message queue architecture. So in between two microservices, I'm going to set some kind of message broker. Microservice A will send the message, and the message will be in the queue for that microservice B. Microservice B can be, slow worker, can be lazy worker, and it's gonna take one message, process it, take another message, process, or it's gonna be one really agile worker who said, give me 10 messages at the same time. It's gonna make 10 different threads and process those messages in the same time and get me next 10 and next 10. But for example, if microservice B for some reason stops working at all, if we had this synchronous blocking interaction, that money transfer will fail. And we will lose the money. But with this asynchronous, that money transfer will stay in the broker until microservice B is back up and starts consuming the messages and processing those. Let's say money transfers. And then we say hybrid. I say here best of both worlds, but does it has to be like using both types in the same time? Are we like mandatory to use all of them? And is this graph that I'm showing here the best way to use them? Well, it's not. Every problem is having the best solution for it. Every processing idea will have appropriate idea in combination of API requests that should be synchronous and some queue messaging queues that are asynchronous. So in this particular example here, we're having microservice A making an API request against the microservice B. And microservice B is taking that request and messaging it to microservice C. Microservice B doesn't know if the microservice C read and processed the message that it sent. And microservice B can only return like, okay, I accepted the message. And microservice A will know only that microservice B only accepted the message, not processed it. And if the microservice C is like a fragile one or really important one, those messages are really important for us. We want to make sure that every time microservice C is having any problems, we make sure that all messages are successfully processed and that the data that are coming to the microservice C is properly saved. For example, if microservice A needs a response, then for somehow microservice C can send another API request or another message to microservice B, which then will be consumed from that Kafka broker again or message broker again. And then we can make a request against microservice A saying like, oh, you remember that request that you made like a few minutes ago? Now it's processed and we are sure that it's saved, and you can tell your clients that everything's fine over there. Once again, find your own and the best approach to the combining these two ways of communication between services. Make a brainstorming session. Think about it. Think of all possible events, all possible, let's say, scenarios that can happen, and why is one scenario, more important than another, or how can you, let's say, solve, or how can you predict some possible issues and solve it with the message brokers. It can be Kafka, it can be Rabbit, whatever you want, just make it like work. And it can be differently consumed from those messaging brokers. You can make a completely random, let's say not random reading, but not every broker is having like, let's say, one topic. Broker can have multiple topics, and multiple services can read from the same message broker. So if you want to like make some kind of broadcasting of messages to multiple microservices, you can just write the message into one message broker, and multiple microservices can read from that same message broker and process the data different way. It's very, very large window of opportunities how to use this. Let's think about how, using one approach versus using another approach will cause any problems. For example, this is one completely synchronous list of calls. So client is making HTTP request to basket, then basket is making another to ordering, and then another request is being made against the catalog, and then somewhere else. That other can even be, for example, third-party service or our client, whatever. If any of these is having an issue, for example, it's down for some reason, then the whole synchronous process will fail. For example, the client may say, I will wait for my response like 5 seconds. And yeah, everything works, but for some reason, everything works kind of slowly. So we're gonna wait 1 second from basket. We're gonna wait 1.5 seconds from ordering, 2 seconds from catalog, 1 second from other, whatever it is. And when you add all these waitings, let's say all those time frames that needed to be processed, it will exceed that 5 seconds time to leave the client is waiting, and it can fail again. I mean, it will be processed, but the client will not wait for you. It will just say, just cut them off and I'll continue working because I have other things to do. The other approach would be, let's go fully asynchronous. And we have now one HTTP request from the client to basket, and then basket is making a message to ordering is sending to catalog is getting updates from some third party or other service, and then maybe we are messaging back to basket. No one will ever be able to say for sure when the basket is going to get an answer from the catalog. Who knows when it's going to happen? So we want to make sure that everything works. When it will be done, we don't care about it. But client cares. Client needs response. Client needs the answer. This is done. Or if the client says, I cannot wait no more, please give me the status. That the status of everything can be wrong because not all messages were read on appropriate places. And combining these two approaches is based on, making good requirement and defining the trade-offs, what you want to get and what you want to, trade with. I need this, I will trade with this. And I would really like to hear from you guys. I would really like to hear, did you have some similar, let's say, problem? Did you have some similar situation when you had to make some trade-off to lose something so you can gain somewhere else? To lose opportunity to get an answer in order to save the data for sure, or something like that. And I already mentioned the third-party integrations, those are hard ones. And I hope that you're gonna hear something interesting from Miloš about it.
Thanks. Thanks. So third-party integrations. Well, usually when you think of third-party integrations, it's kind of similar like microservice, but that microservice that you're working with is a black box. So, and you can't control it, nor anyone from your company can. So as most of you know, third-party integrations are integrations usually between two services, obviously similar to microservices, and it's usually business to business. For example, if your company is an e-commerce company and you want to have payment system on your front end, you want to integrate with a bank or PayPal or somebody like that to handle that part for you. So we'll skip the implementation details because they vary a lot. I will show you some practices and pitfalls and everything else that I know of, that I've encountered. And yeah, so why do we need third-party integrations? So it's faster to implement. Somebody has already figured it out, and we don't have to do it from zero. So usually we don't have enough time, and it's faster to implement. Usually, not always. As I mentioned, somebody has it figured out already. It's cheaper, but usually, not every single time. So you have to take, if you're a new business, you have to consider the pros and cons, the trade-offs, if you want to implement something or pay money for the integration itself. The company that you're working with, that you're integrating with, usually has the domain knowledge that you might not have. So the added benefit is that you have somebody to ask, hey, my clients want something like this. Is that possible, or is that just shenanigans that they're talking about? That all brings us better experience for customers, for users, and brings value to the company. So what are the drawbacks of third-party integrations? Just to keep in mind, these drawbacks aren't just drawbacks, but more like questions that you have to ask the providers, because they do happen, and you want to know in early stages what's going on. So each and every one of the items on the list I'll show next, you want to ask them first, or in the process of development. So you want to know what are the limitations in their service. For example, they might not provide you with enough data you need, or they don't have enough features, or you want to make multiple calls to their API to get one thing. That's all bad practice usually, or that's a limitation in their service that you want to know ahead of time, ahead of developing. Performance. Sometimes they lack performance, like slow responses, rate limiting, and something like that. For example, rate limiting could be mitigated by having multiple instances of the same service. So you have, if it's IP, if it's a IP whitelisting or IP blocking for that rate limit, you might want to call it from multiple IP addresses to get a better performance. Thing that happened to me here is that you have single sign-on from Microsoft, and they have too many requests. You can sign in, which is really bad sometimes when it's really needed for you. Maintenance. So some of third-party providers will have maintenance issues, like they won't tell you when they update their service. They won't tell you when they update their requests or responses, and that can bring your system to a halt. So the thing that they should do, and this goes to if you're a third-party provider, you want to make something like that, like what I talked before, dependency that's backward compatible, at least for some time, and let the users know that you've changed the implementation. Bad documentation. This is usually what happens. They don't have enough documentation that's good enough, or it's not readable enough, or it's another language, which happens to us. So you get documentation that's in Spanish. You have to find somebody to translate it, and you have to work with them. So it's not easy to do that. And when they have that communication, you have to have good communication with the provider. Like, you have to ask a lot of questions to them, like, how does this work? Can we test this and that? And you want to have limitations in their service, the first point, in the documentation, so you can count on that. And sometimes we don't have a choice. As I've said, we have to integrate with somebody. Maybe it's a third-party provider that's only one or two of them in the world that have the thing that you need. So you don't have a choice. Either you implement it yourself and it takes for years, or you implement there, or you integrate with them and it takes like a couple of months or weeks or whatever. Lack of staging environment. This is self-explanatory. You don't have staging environment, you can't test, you can't do anything before going live. It's maybe okay, depending on the circumstances, if you have test credentials for the production. But speaking of which, what if you do have staging environment, but it differs from the production? Well, that can be a big of an issue. In the last company I worked at, we had an issue that we developed for like 6 months or so, or even more, third-party integration that was necessary. And once we passed the certification, we passed all the tests, we got everything, we got a green light to go into production. Well, we deployed to production, and what happened? Well, they said it doesn't work. Why? They didn't have exactly the same environment like staging was. They lacked only one field, and that field was version. So the stupid version field brought everything to halt. We had to, so first we waited for like 3 or 4 hours for migrations, and then you have to roll back everything and test if everything is working correctly. Then you have to communicate with them. You have to test everything again, to implement everything again, to maybe again pass the certification because you made changes, and then again deploy to production and hold your fingers crossed that it works this time. Yeah. So speaking of certification, it's good and bad. It's good in a way that you have to do something correctly. They will certify you, so it's a good service, it's stable and everything. But it's a con because it takes a lot of time. You maybe have to develop even more things that you need than that you need. So for example, you need only one feature. They require in certification to have 4. You don't want those 4, but you have to implement them anyway. And the last one is support. If you don't have good support, it's bad, obviously. So you want to know before everything, how much support are you getting? Do they work on holidays, for example, or weekends? Because for some companies, deployments are happening at weekends, and you want to let your users know that you're going to have a maintenance period of few hours or whatever, and you want to check on their end with their support if everything is working. So you want that. Tips. This is like kind of addition to the previous part. So the previous part are things that you want to keep in mind, to ask, to investigate, and these are just some tips of how to solve some of the issues. So for rate limiting, as I've said, you can have multiple instances of one service that calls their API. So each new IP address is like a new client to them. So rate limiting, possibly, not always, will be better. So lower, they'll have lower rate limit. And see if they maybe have an endpoint that returns a list instead of a single item. So you get like 500 things instead of one. That saves you 500 requests, probably. I mean, it's just an example, but you have to spare those HTTP calls. You want to have default fallbacks for what they're doing. So if their service falls, if their server is down, you want to still have your server ready to work. You don't want everything to fall because they did. Choose provider based on docs and support. This is a thing to consider, not a requirement, not a must. So you want to choose a provider based on documentation. That means if you have 5 providers, try to get documentation from each and every one of them and read it, see if it fits your business model, and make a decision based on that. Not just that, but based on that. As I've said, ensure that the provider can scale with you. So if they can't provide you with enough fast or if the fast responses, or if they have rate limits, you have to work that out. And again, if you are a provider, provide SDK, Swagger, WSDL, or something like that, because it will speed up the development, it will make it much easier and everything like that. testing. So you can't make automated tests that target their API. Why? Well, you want to have consistent tests that work in each and every one of your environments. So in local, in CI/CD, in staging, in integration, in every single one of your environments, you want stable tests. But you also want to test them. And that's done manually, but there's a catch. You can write automated tests that target their staging API, if they have one, or production with test credentials, if they have one, and use like a hybrid combination of mocking their API and manual testing. So the automated tests and manual tests. So if you have automated tests ready, somebody from QA will have to trigger them on purpose, so they're not fully automated, and that maybe covers 70 or 80% of what they can, and the other 20 or 30% should be done manual. Security, authentication, you have to see what they provide. Is it per user, per request, business to business with API key, or is it a combination of that? You want to know if they do IP whitelisting, that's a good thing, and if they have mutual TLS. Mutual TLS, for those of you who don't know, is a TLS certificate that both server and client have. This has advantages, but also disadvantages. So, for example, it's a good server-to-server security, and it's good because it's working like in the combination of IP whitelisting. But what if you have multiple servers? How will that be handled? Do you have MTLS for each and every one of them? Do you know when it will expire? Usually tests do have that, but you have to know because you don't want to have downtime. And how fast can you do that? How fast can you change that MTLS certificate? Some of the tools that I use for development and testing. Simple CURL. Colleagues in the previous company laughed at me for this, but I think it's a great tool. They laughed because I was using it maybe too much, but it's a great tool to debug the request before you even make the code in Java or whatever you're using. So you get, when you put verbose tag, verbose option in curl command, that's a command line tool, by the way. You get like everything from server handshakes, you can test MTLS certificates, you can test everything like that. Wireshark, when you develop the code in Java, you can test the requests and responses with Wireshark. It's easy to use. It provides you a lot of information similar to CURL, but it's harder to use. And again, Swagger, WSDL, or SDK would be greatly appreciated. And for my last part, it's a pro tip that I learned in the last company, that you should evaluate your integrations from time to time. What it means is that if you have an integration that's lasts a long time, you might want to evaluate it and see if there's any third-party provider, or can you do it yourself. In the previous company, a colleague of mine, he developed third-party integration, like, I'm just gonna say, like 5 years ago or more. And our company paid thousands of dollars per year for that integration. They had downtimes, they had issues with changing their requests and their responses. And the drawback was that probably they were the best to integrate with at that time. Well, a couple of years later into that integration, he had enough test data and enough knowledge to do it by himself. If I remember correctly, it took him about 6 months to develop, and that's besides his casual work. So he developed in that period the replacement integration to go into production. And as you know, you don't, but it worked like a charm. It worked from the first time. So he developed everything by himself. Of course, there were testers and everything besides that. But he provided many benefits to the company. He integrated that, and it provided no more downtimes, which was important because our business was hanging on that. Also, the maintenance, there wasn't any because it's now integrated. No more payments, and most importantly, he saved a lot of time for consumers of that API or that feature, and the developers that were working to support that. And so, moral of the story is evaluate integration from time to time. Try to make it yourself, or see if there's any third-party provider that might fit better. That would be it from my end. And Nicola, if you have something, if not, Bojan will take over.
Yeah, so we are at 1 hour. So I would just like to take attention to try to speed it up so that we also have a few minutes for the questions as well.
Of course, Nicola, thank you for noticing it. We're gonna wrap this up with monitoring and alerting. This is like the crown of everything that one microservice application needs to cover. So when we talk about monitoring and alerting, we want, and again, generally about our services, we want to make sure that our system or our services is all available, it works fast, it works correct, everything's fine, it's efficient, doesn't spend too much money for us. I mean, it's like flawless thing, just like the thing that you can see in the picture on the right. But in reality, the systems, especially on the back, are kind of complicated and really they break often and really a lot. So instead of having that beautiful picture, I always imagine the system like this, which is not good, but prepare for spaghetti code. So solution in making sure that everything works fine is definitely in good and reliable monitoring, and especially not only monitoring, something has to alert you if something is actually not working properly. So what are the problems? I'm sure that at least one of you here forgot to check the disk space on your database until it hit 100%. And then you stop getting new data or something like that. So it's really important that you can when you should do some at least cleaning up the database or expanding the storage capacity. Or someone introduced a new feature that had some secret bugs, sometimes showing up or not, some exceptions, some NP, some array out of bounds exceptions, something stupid that you maybe didn't catch in testing phase, or even after the deployment, you couldn't catch up. You couldn't see the errors, but you can see the difference between before and after the deployment happened, for example. Or something is wrong with our network. You know, the Facebook had a problem, and trust me, they knew they had a problem before the clients told them, yeah, we have a problem. Or some third party that you rely on, they are having some outage. Everyone is having an outage today, especially those companies that you rely on, your services are relying on. It looks like that those are having outages most of the time. Why are we paying them? I mean, or your service is making like low or high memory utilization, so you're wasting your money, or your system is underperforming. Should I increase or decrease the memory there? Or maybe some fan went off and my whole server is gonna blow up because I have too high temperature. So anyone thirsty? Because I am. And the first thing that I'm going to tell you about is, please, when you use your microservices, implement some application performance managers. I'm having this image here. I'm not going to tell you the difference between Datadog or New Relic, but I'm going to tell you what you can gain if you implement any of them. If you implement any of them on your microservice, you can see what's going on there. You can actually go inside and see the response times for any API requests around that are going. You can see if there is that one query in the database that is having huge troubles, that is taking like 80% of your CPU because you missed to hit that indices in the database. It will show you where in the workflow you're waiting most of the time, which service is the slowest one and which service should be improved. Or if you're having multiple pods, multiple instances of an application, maybe you should think about increasing the number of pods just to make sure that everything works smoothly. And that's why I'm saying, like, you go into Datadog or New Relic, just play a little bit, search, explore, research about things, and you may see many different, and you'll see something astonishing about your microservice that you maybe didn't even know. It looks like it works okay, but it could work better. It could save some money for you. I want to see the logs. I want to see the status. I want to see how things are going before and after. Once again, I'm not going to talk about differences between Kibana or Grafana here, but I'm going to say that both of these tools also, although different purposes, but they can show you things that you cannot see just while reading the logs or searching for the logs. They can take the log raw data from many places, from Elasticsearch, from Prometheus. It can show different things. What you can do, you can set some different, let's say, alarms, some different rules, some different states of the services. And what should you do when you do that? First of all, when you're setting up your alerting system, you have to understand your system. You have to know what are expected values and metrics. You have to know how you expect the service to behave. What is the number of calls that your service is getting? What is the number of calls that your service is making towards third parties, to third-party services? After that, you have to define rules, thresholds, and the critical points. When you want to be alerted, is it when it gets below some value? So you're not having a traffic. Why you're not having the common traffic that you are expecting today, or the traffic is skyrocketing and your system cannot hold? Then you have to definitely create proper queries and set up alarms. You can use Elasticsearch. You can make something like Lucene queries. You can make SQL queries. And please, when you do this, you always have to consult your workers, especially if they are working in different teams. Which rules should be set for different team? So every each team member should be familiar with the rules, with expected values, with expected metrics, and should be aware of those rules that you're setting, alarm rules. Definitely, every single team member should know when its on-call shift is. And after that, you want to make sure that after the problem is happening on your system, you want to know about the problem before the mad customer is calling and saying, yeah, this is not good. We are having huge problems. So everyone has to know for what they can be paged, they can be alerted about. And when everyone is properly set, every team member, every rule for a certain team, and when, not if, because outage will eventually happen, then you will enjoy your outages. That outage solution should not be like a huge dramatic scene. Everything is on fire and people are running around, hitting each other, meeting each other, hitting each other. So everything can be like calm, because I know this rule is because of it. Yeah, probably that happened or that happened. We had this deployment, so this is new feature. So this feature probably caused this outage. I know it's when we have like a microservice that has like more than 20, more than 50 microservices there, it's sometimes hard to catch possible problem that will happen somewhere downstream, but this alerting system will help. And always, whenever you're having outages, try to enjoy on those meetings, especially PMAs, because they are the fun part. Thank you for listening to us, and we will be more than happy to go through the questions that I saw that some attendees wrote in our comment section. Of course, Nicola, if you have some other question, we would be happy to hear from you. Feel free to ask.
Sure. So I'll show up a question from one of the guys. So I also have a couple of questions. Let's try to keep everything at least below 15 minutes altogether, so that we wrap up in 1.5 hours for the whole event. I'm assuming that those that are sticking around still after 1 hour are willing to hear the answers to the question. So let's extend it a bit. My question first for Miloš, when it comes to like API changes that happen, and like okay, yeah, of course you need to have like a version 1, version 2, but like what happens in reality is that like you make those version 1 to version 2 over a very, very long period of time. And while you're still on the version 1, you do have kind of a stuff that you need to kind of fix under the hood, and kind of make changes to the code and maybe even the structure of the database. So, and somebody's already using your API. So like what would you highlight as kind of the best approach for that, how to handle that in kind of real world scenario to keep the service up and running, and like with the least disruption until the version 2 comes in and with fully new documented API.
Yeah, so of course the format should stay the same as much as it can, but if you're a provider for that API, you want to let the customers know. So we had that issue that there was a, not sure how Americans call it, like sunset for the API. That means that we have like we're giving you a year of support for this API, and after that it's not going to work. So you have to force users to migrate to a newer version. Of course, it will happen that you need to change something underneath, but really, in reality, things change, and it happened to us. You will probably sometimes be the provider that breaks changes to other users, which is unfortunate, which is why there are best practices, but not everyone uses the best practice. Especially us developers, we understand that, but the managers and everybody else is like, go with it, delete it. We don't care that much. They should upgrade anyway and similar. So that's kind of an issue. So it's not on our end all the way. So we have somebody to blame, not us. But other than that, yeah, you should use versioning. You should make it as stable as possible. You should let your users know that you're going to change that. Give them some time frame before, and like obviously, if you have an open source project, for example, you want to keep it alive as long as possible. If not, make an archive, so at least users can download it even if it's too old. But sadly, that's not what happens in the real world. And if it happens to you that somebody does that, you're in trouble. You have to fix that as soon as possible. It happens. There's no way around it, sadly.
Well, you can also kind of use kind of application level logic to kind of make sure that even though things change underneath, that the exposed API stays the same. Like,
of course,
in PHP,
yeah.
it's something like that we at Product High work. It's like transformers, and I'm pretty sure that like there are similar stuff in all the other languages. Cool. Let me show. So Milan asked a question: which orchestration? Actually, asked 3 in 1. Which orchestration for microservices are you using? And what challenges while hosting microservices for scalability and hosting?
I'll go out of the order. Yeah, I'll go out of the order here. So, because first of all, challenges with hosting microservices is the biggest and the worst challenge is migrating whole microservice architecture from one hosting to another. For example, moving from AWS to GCP. So, or moving from any to any. Please, guys, the best thing that you can do is like
pay more. Stick with
either that, make good foundations for your application. That's like the best thing. Also, the thing with okay, right now I'm gonna make the Java 8 applications. Everything's gonna be there. So yeah, I'm gonna stick. But if I need, I'm gonna make it 11 or 17 eventually. But and then a few months later, like, oh, we're gonna stop supporting Java 8. Oh my God! So I have to upgrade Java, or I have to upgrade Spring, or I have to. So those things are really, really painful. It takes lots of the programmers' engineering time. It's really, so make a good foundation. It's basically the same when you create a bad database without indices. You make a base bad architecture, and when you have to improve it, that disturbs many things. So you have to think kind of ahead. Pay a little, just like you said, pay if you need to pay just a little bit more to make sure that you're not gonna change the hostings all over the place.
Yeah, and if I may jump in here, there's also like different languages again have different solutions, but like if you can use a service which kind of abstracts the details of one particular provider and allows you to kind of easily switch between the providers, like we are using like building applications in PHP Laravel, and like they have really good deployment services. So like there's Laravel Forge, which kind of allows you just to quickly and easily literally just choose different server to which you want to deploy, and like all your deployment scripts stay the same. You just kind of authorize on yourself on the server. Like, and I'm pretty sure for Java, maybe that's not the case because everything's more complicated with Java. but with other tools, like that's also a thing to kind of be aware of. Like if you have other tools, even if they're kind of premium and you need to pay like a monthly fee, it saves so much time and the flexibility that you get down the road of potentially switching at one time. When the costs on whatever AWS or Google become too big, and which are much cheaper on whatever Hetzner, Walter, or whatever, you can easily switch. These are my 2 cents on the topic.
Thanks, Nicola. It's really
sorry for jumping in.
Mention that. No, absolutely. Thank you for that. And about the orchestration of microservices, it depends on project. Some of the projects are better with non-orchestrated, so like they're having that choreography structure. Some of them are having like some main central application that will coordinate and orchestrate everything else. So it really depends on what you actually are building. And that's why we are coming back to the foundations. Make a good foundation. Sit, brainstorm, decide about the architecture, and then go with it. That's basically the main thing. Always spend a little bit more time in making a good foundations for your application, rather than spending more time after fixing the bad foundations.
Mm-hmm. And is there a specific orchestrator you would recommend?
Also, depending on a language, in Java, mostly Spring. It's gonna take. If PHP, there's gonna be Apache, right? So depending on what you build and how you build it, definitely.
Mm-hmm. Cool.
Yeah.
Let me pull up a couple of more questions. So when testing third-party integration, would you recommend some other tools outside the tests? For example, Postman, or you think curl is the best option? Greetings to his or her good friend.
Thanks for that question. Yeah, so testing, when you develop on the server end, you can test, if you're a developer like me, you can test with Postman, of course, but that's kind of a part of a manual test. I know Postman has automated tests, but we're usually writing them in code, so in Java or whatever you would be using. We use hybrid, like you can test some part of it automatically to run the tests, because that part gives you the stability. If their service is down, you're not bringing everything to a halt, like your build pipeline or something like that. And you mock everything else for fully automated tests, and you do the rest with manual, be it on the application, like on front end or iOS or Android, be it with Postman. Those are just the tools that you're using to run manual tests.
Cool.
I would like to add something. Yeah, I'm sorry for microphone. Yes, the tools, the ways for testing are kind of irrelevant here. The problems that I actually saw is that our third parties are not having proper testing environments, or they're having their sandbox, which is not the ideal replica of their production. And we were testing something against their set testing environment, sandbox environment. And when we actually put the code in production, it was behaving completely different. Why? Because they're not having the proper test environments. I would say that really important part of the testing, especially if it's working with third parties, is to make sure that their test endpoint is working as expected, the same way as the production will work. And if they do not have, which happens really often, they don't have like test environment and they don't have sandbox, please ask them to create like a production test account for you, which will be only for testing, and we should be ignored on their side or whatever, but make sure that you test properly your integration with third party. Thanks.
Cool. Thanks for that, Boyan. While we're on that topic, like, are you in for the stand that like there should be the exact replica in terms of the size of instances, for example, which are on production should be the same, or more in terms of just the kind of environment, which means the network, kind of VPCs, what's private is private, or are you like saying that it should be the exact replica, meaning the size of instances as well, so they behave exactly the same, or it's actually advisable to have smaller instances on dev and staging?
So usually you don't care. I mean, the most important
if you're
thing
not
is
paying
that
the bill, maybe.
Not that part. The most important thing is that they work the same. So same data, same everything, same authorization, same everything. We don't care about the size. So the staging environment can be 1/100 of a production. Nobody needs to know that, right? So the only thing that we need to care about is that literally everything is working the same. So again, that Boyan said and I said, it needs to work same in the staging environment as well as in production. We usually don't care about their architecture. So yeah.
Cool. We have a couple of more questions, but since we have to wrap it up, I'll just kind of open something for debate. And I was especially intrigued by mentioning like the whole kind of how you handle logs, and especially a topic that I'm interested in is large amount of logs. So we are building internally a startup called Meetup, which kind of sends really large campaigns, SMS messages for customers, or Viber messages, or whatever, multi-channel. Like we get, some campaigns might have, let's say, 500,000 messages that we need to send. And again, every message sent gets like 5 receipts back on the status of the message. So we get that all back on a webhook. And like we now need to kind of build infrastructure that supports that kind of consumes logs in real time with a lot of these restrictions that you're talking. So like rate limiting towards the provider. And again, the huge influx of requests that's come to our, and again, you talked about Kafka and potentially Kinesis as an alternative on AWS as a managed stream service. But again, you're advised, and you shouldn't just send them one by one to Kafka. I mean, you could, but it's not efficient. So you would have to kind of batch them somehow. So have you done this process in particular in the past, or have an idea how to efficiently handle it in production?
For example, Kafka and all those messaging querying systems are mostly working better with small messages in a really large amount of them, instead of having like small amount of the messages that are like kind of huge. And definitely having the consumer on the consumer side, definitely having the batch that is consumed and then processed in parallel, if possible. That's the best size, let's say approach. But when you are creating a batch on the let's say publisher side, I would rather change the model, sending a few messages inside one message. Let's say I would squash that 5 messages that you want to send inside the batch and send it as a one message, so it can be processed properly and function, let's say, as it's meant. But it depends on how you define your.
That brings us to the other thing you talked about. It's a trade-off. So this is kind of a trade-off we are facing right now. So additional aggregation of the data in order to send less, because AWS, for example, charges you on the amount of requests that you send through Kinesis, for example. So that means if you send a lot of small messages, the bill will add up really quickly. So you're actually forced to batch them up so that you don't pay a huge bill. So like there's a lot of interesting problems, and it does sound easy until you kind of scratch the surface, but especially kind of the logs and like building this whole kind of and stream that you talked about. It's quite we're in the middle of it. So I'm quite interested to talk with you on that topic a little bit more, to hear your thoughts on the way how we're implementing it at the moment. But
trade-off is definitely the thing that every one of us has to make, and not only in programming, but I have a friend who once had to make a trade-off in going on a date or completing a feature till the deadline. So always trade-offs.
What did he do now?
I'm gonna leave you with a cliffhanger here.
Cool. I think that's a great way to end our session today. I want to thank you both for doing this talk and sharing this information with the audience, for answering questions. Thanks for Q-Series for being the sponsor of the event and making it happen. Thanks to guys at No Limit Hub that made it happen. And lastly, and most importantly, thanks to all of you who are watching this either live or as a recorded session later on. Make sure you follow, subscribe, and like everything that No Limit Hub and CODEstantine do. And I would like to end it with that. Thank you very much, all of you, for your time, and see you in a couple of weeks on the next one.
Thank you for having us. Bye.
Bye.